Next, we have ultrasonic controls, and basically you have a sensor that sends out an ultrasonic sound wave, bounces off the roll, and that sound wave comes back to the sensor. The sensor measures how much time it takes to do that and gives you an output relative to this radius. So as this, on an unwind, as this radius is getting smaller, the time it takes for the sound wave to bounce off and come back is taking longer, and it literally gives you, it can measure roll radius and determine roll radius with that ultrasonic sound signal. The sensor tells the control what the radius is. The control tells the drive on an unwind to decrease torque, and again on the rewind, increase torque. Some advantages: they are actually very simple. They are an excellent replacement for manual control because they're easy to get, they're easy to install, they're relatively inexpensive today. They do give you a true linear output relative to roll radius because the position of the sensor is linear to the radius. So whereas the follower arm, you have somewhat of an arcuate motion, so the torque output is not completely linear to roll radius change, whereas the ultrasound is a straight line measurement device, and that will give you a linear output to your torque device. They do have compensation for out-of-round rolls, so if you do have egg-shaped rolls, they normally have some averaging logic built into them so that you can eliminate oscillation due to out-of-round rolls. The sensor can be mounted completely out of the way of roll changes. Unwind and rewind capacity is very easy to change because all you have to do is move the sensor and just maybe do some programming changes on the sensor itself to get it to sense a longer distance. Let's say if you're putting bigger rolls at your unwind. There's no mechanical parts to wear out. You can get these controls with limit alarms, so if you want to know when your unwind is very near the core, you can light a light or sound a whistle. And there is no contact with the rolls of material itself, so if your roll is sensitive to being touched, this item obviously doesn't touch the roll itself at all. Some disadvantages: it is open loop, so it doesn't know what the tension is in the material. Again, this type of control is just giving you an output relative to radius, so it can only control unwinds or rewinds. Foreign objects can be sensed. I've seen in the field where if something gets in the way of the ultrasonic sensor and the roll, it's going to pick up an item, any item between the roll of material and the sensor itself. So if anything can get in the way, that's going to give you a false signal. They do require electronic calibration from time to time, and signal absorption is a problem if you have materials that may have a tendency to absorb that ultrasonic sound wave, basically, and not allow the sound wave to make it back to the sensor. That could cause you some issues or false signals. Perpendicular positioning the sensor is critical. It does need to be positioned relatively accurately to the center line of the roll. If it's not perpendicular to that roll, it's sort of like if you throw, let's say, a basketball at a wall. If it's not traveling perpendicular to the roll, it may not bounce back to you. It might bounce off to the side or up or down, and the same kind of principle works for the ultrasonic sensor. So it isn't, the positioning is somewhat critical to the system.